Hey guys, this is Ray, your AI Automation Alchemist, and I'm under the weather this week, which has prevented me from creating the next episode on ChatGPT, which is supposed to be episode 9. As I mentioned in my previous episodes, I'm committed to creating 30 episodes in this podcast in 30 days as part of a 30-day challenge that I agreed to when I first started this. And this is why I'm uploading a bonus episode for you today, because obviously, since I'm under the weather, can't create a new episode. Hard to record. Just to set the stage, I was trying to explain in a previous episode of how large language models work, and I completely butchered it, I believe, in my opinion. And if you understood it, great, then bless you, obviously, because it was a hard one to try to explain visually and verbally. But if you're still confused, I had an epiphany where a story came into my mind that would be perfect way to explain how the back end of an LLM works, which is a large language model, like I said. What I did was I spoke my story into the notebook LM that I came up with in my head, and and then I had it create an audio and video version of the story. Since Notebook LM does a great job of synthesizing your ideas into easily understandable content, the video turned out great, and I inserted it into the last podcast. If you heard the last episode, I inserted about halfway through that episode, and again, it was pretty easy to understand. But this bonus one here is the audio version, is the audio podcast that it created, which has more detail than the video one. It will give you a solid understanding of the behind the scenes of how these different large language models work. They all work very similarly. So ChatGPT, Claude, all the different ones that are out there. And the real difference between each of them is the data they use to train those models, as well as the fine tuning that they use in order to improve the models themselves. But again, I won't bore you with those technical details. So enjoy this Notebook LM version of my analogy of the large language models through story. And don't forget to like and subscribe to the podcast to receive notifications on new episodes. I'll see you in the next one.
The most real and relevant resource on AI and automation. AI Automation Alchemist podcast, sponsored by Grata Software.
To be honest with you, every single time I decide, okay, today is the day I am finally going to understand how a neural network actually works, I hit a brick wall. Mm-hmm. I open an article. I feel pretty smart for about 2 sentences. And then wham, I'm staring at a diagram that looks like a plate of spaghetti exploded onto a spider web.
Oh, I know exactly the diagram you were talking about.
Yeah.
It's always circles connected to lines, connected to more circles, usually with some scary Greek letters thrown in for good measure.
Exactly.
Yeah.
It's the Sigma notation that breaks me. My brain just checks out. It goes, nope, we're done here. Let's go watch cat videos.
Yeah.
It just feels like this impenetrable black box that only PhDs in math are allowed to open.
You are definitely not alone in that. There is this massive gap right now between the people using AI, which is pretty much everyone, and the people who actually understand the architecture. Yeah. It is notoriously dense material. Wow. It's usually explained by engineers for other engineers.
But today, I think we have found the antidote. We found a source that claims to explain neural networks, transformers, and this, ubiquitous buzzword RAG.
Mm-hmm. Retrieval Augmented Generation.
Without a single line of code, no math, no spider webs.
It is a brilliant take. We are diving into an analogy created by Ray Ortega, who's the CEO of Grata Software. Okay. He wrote a piece called The Neural Network Party. And frankly, it is the most human explanation of AI architecture I have ever come across.
It really is. The premise is that we can understand the most cutting-edge AI technology just by visualizing a flat tire and a cocktail party.
I know, it's great.
So if you've ever felt like AI was just magic, or if you've been nodding along in meetings pretending to understand what a hidden layer is, stick around. This is finally the explanation for the rest of us.
And what I love about this is that it shifts the perspective completely. We aren't going to talk about data packets moving through silicon chips.
No.
We are going to visualize information travel as gossip at a cocktail hour.
Which, let's be real, is a system I am much more qualified to understand.
Right.
I get gossip. So let's unpack this. The analogy actually starts before we even get to the party. It starts on the highway.
Right. So the setup is crucial here because it establishes the ground truth.
Okay.
Imagine you are driving to a high-stakes networking event. You are all dressed up. Maybe you're rehearsing your elevator pitch in the mirror. Well, in the rear view mirror.
Feeling good, feeling confident.
And then boom. Thump, thump, thump.
Oh.
Flat tire. You pull over to the side of the road. It's the classic nightmare scenario.
Worst.
You are probably stressing out about being late, worrying about getting grease on your outfit.
I can feel the anxiety rising just thinking about it.
But then salvation arrives. A roadside assistance truck pulls up. The driver gets out, walks up to your car, and you realize, you know this guy. It's an old friend from high school.
And the source specifies this wasn't just any friend, right? This was the guy voted most likely to succeed.
Exactly. That detail is really important. In technical terms, we would call that a feature.
A feature, okay.
It's a specific piece of data attached to this memory. So he is fixing your tire, and you two start catching up. He tells you his whole life story, how he ended up in roadside assistance, what he's been doing for the last 10 years.
So this is a direct experience. I'm standing there on the side of the road. I see the uniform. I hear his voice. I smell the tires. I am getting the raw, unfiltered story directly from the source.
Precisely. You are collecting the raw data. So the tire gets fixed, crisis averted, you get back in the car, you speed to the networking event, and because maybe you drive a little too fast, you actually show up early.
Miraculously. So I walk in, and the room is mostly empty. There are only about 5 people there, just hanging around the bar, probably awkwardly checking their phones.
And because you are bursting with this weird coincidence that just happened, you walk right up to them.
I can't help myself. I say, you guys are not going to believe this. I just ran into my old friend from high school on the highway. And I tell them the whole story. The flat tire, the most likely to succeed, backstory, the repair, everything.
And here is where we pause the movie. In the architecture of a neural network, those first 5 people you told,
Yeah.
they are the input node layer.
The input node layer. Okay.
Yes. They are the entry point. You, the user, had the experience, but they are the first nodes in the system to receive that raw data.
Got it.
Now think about this. You told the story to 5 people, but they are 5 different people. One might be listening really closely to the emotional part of the story.
Sure.
Another might be focusing on the car details. Another might just be nodding politely.
Right. They all receive the same input, but they might be holding on to slightly different pieces of it.
Exactly. They hold the initial state of the information.
Okay, that's simple enough. 5 people, 1 story. But a networking party doesn't stay empty for long.
No.
If it's a good party.
No, it doesn't. And this is where the network part of neural network really kicks in. Scene shifts. The party fills up. Suddenly you have 50, maybe 60 people in the room. It's loud, people are mingling, moving from group to group, clinking glasses.
And those original 5 people, my input nodes, they aren't just standing in the corner anymore.
No, they are mixing in. They start talking to the new arrivals. And what is the most interesting thing they have to talk about?
My flat tire saga.
Exactly. They turn to a new person and say, hey, did you hear? That person over there ran into a high school friend on the highway.
And then the people they told go and tell other people.
And someone who heard it from the second person might bump into someone who heard it from the first person. The information is literally rippling through the room.
It's the telephone game. We've all played this in kindergarten.
It is the telephone game. And in neural network terms, all these party goers, the 50 or 60 people in the middle of the room, they are the hidden nodes.
You know, hidden nodes or hidden layers always sounded so mysterious to me. Like they were hiding secrets or some kind of black ops thing.
I know, right?
But in this analogy, they're literally just the crowd.
They're just the crowd. They're called hidden simply because they are sandwiched between the input and the output. They are the processing layer.
I see.
But Ortega points out something really fascinating here about how learning works in a neural network. Because when humans play telephone, we don't just repeat words like tape recorders.
Oh, absolutely not. We embellish, we forget things, we add our own spin.
Yes.
If I tell a story to my dramatic friend, it comes back as a Greek tragedy.
Right. And that is exactly what a node does. In a neural network, every node has what we call weights and biases.
Okay.
Now, don't think of bias in the social sense here. Think of it like a filter or a personality quirk.
Okay, let's unpack that using the party guests. What does a bias look like at a cocktail party?
Imagine one of the guests at the party is a huge action movie fan. That's his bias.
Okay.
So when the input node tells him, the friend fixed the tire on the highway, this guest's brain goes, roadside assistance, highway, he must be tough.
So he fills in the blank.
He fills in the blank. So when he turns to tell the next person, he doesn't just say he fixed the tire. He says he fixed the tire and wow, the guy was built like a tank. Huge muscles.
Even though I never said that.
You never said that.
Yeah.
But the node inferred it based on its internal logic, its training.
Right.
And then there's weight. Think of weight as how loud or influential a person is. If the gossip comes from the most charismatic person in the room, the next person is going to believe it more strongly. That
Mhm.
connection has a heavy weight.
So as my story travels across the room, hopping from person to person, layer to layer, it's changing, it's evolving.
It is gaining texture. The network is trying to predict and reconstruct the story based on the collective patterns of the crowd.
Mm-hmm.
If the crowd has seen a lot of stories where mechanics are strong, they will statistically predict your friend is strong.
So the story's getting thicker with details that weren't in the original event. That's really interesting. It's like the intelligence of the model is basically just the collective assumptions of the crowd.
In many ways, yes. That is why we say these models are probabilistic. They aren't looking up facts in an encyclopedia. They are predicting what the next plausible detail should be based on the conversation so far.
But I can see a problem here.
Mm-hmm.
If I let this go on for an hour and everyone adds their own little spin,
Oh, yeah.
the story at the other side of the room is going to be completely off the rails.
Oh, totally. It's going to turn into he got abducted by aliens who fixed his tire with a laser beam.
Right. If it's just a game of unmonitored telephone, the signal degrades into noise. The story drifts away from reality.
And this is actually a huge problem in early AI development. It's called the vanishing gradient problem, or just simple context drift.
Okay.
As the information gets deeper into the network, it forgets where it started.
So how do modern neural networks stop that from happening? Because when I use ChatGPT, it usually stays on topic.
Mm-hmm.
Doesn't usually start talking about lasers unless I bring them up.
This is where we introduce the transformer.
Okay, transformers. This is the big leap. The T in GPT. How does that fit into our cocktail party?
In Ortega's analogy, think of it this way. You, the original source, the person who actually had the flat tire,
Right?
you didn't leave the party. You are still walking around.
I'm still mingling, grabbing hors d'oeuvre.
Exactly. You are wandering through the hidden layers. And as you walk past groups of people, you overhear them talking about your story. Maybe you overhear someone say, yeah, I heard they met up at a bar downtown and had drinks.
And I can step in and say, whoa, hold on, no bar.
Yeah.
It was on the side of the highway.
Exactly. You are providing the attention mechanism. You are recontextualizing the data. The transformer allows the network to attend to the original input even as the information moves deep into the crowd.
That makes so much sense. So the transformer is basically the host of the party, or in this case, me making sure the rumors don't get too wild.
Yes.
It keeps the context anchored to the truth.
It establishes relationships between the words. It says the word friend in this story is connected to highway and tire. It is not connected to martini or bar.
Got it.
It preserves the logical structure even as the story evolves.
Okay, so we have the input, the hidden layers, and the transformer keeping things straight. Now, the party is winding down.
The night is over. The music stops. Most people have gone home.
Mm-hmm.
But there are 2 or 3 stragglers left standing by the door.
The last one standing.
These are your output nodes. Their job is to summarize the night and give you the final version of the story.
Okay.
But here's the catch. They didn't talk to you directly at the start. They heard the story from the crowd.
They've been listening to the telephone game all night.
Exactly. So before they leave, they talk amongst themselves. They compare notes.
Right.
One says, I heard he was a bodybuilder. Another says, I heard he owns the truck company now. A third says, I heard it was raining.
Yeah, and they don't know what's true.
They don't know for sure which parts are 100% accurate, so they do a quick statistical analysis. They look for the consensus.
To figure out what version of the story seems the most popular.
Right, and then they come up to you and tell back. They say, wow, what a crazy night. We heard you ran into John on the highway. Sounds like he's doing amazing, super fit, owns his own business now.
And that story they tell me.
Yeah.
It's not exactly the story I told the first 5 people.
No, it isn't. It has been transformed. It now has additional context. It has the nuances, the emotions, and the details added by the collective wisdom and the collective biases of the hidden nodes.
This is a huge light bulb moment for me. This explains why generative AI feels creative. It isn't just retrieving a file from a hard drive. It's reconstructing a memory based on the vibes of the party.
Reconstructing is the perfect word. It is generating, not retrieving.
Right.
And notice something. Remember the guy in the story becoming super built or owning the business? You never said those things.
Right, I never said that.
The nodes invented it based on probability. That is what we call an AI hallucination. The crowd filled in the blanks with things that sounded plausible but weren't factual.
Which is great if I want a creative story.
Sure.
If I want the AI to write me a sci-fi novel, I want that creativity. But If I'm asking the AI to summarize a legal document or tell me the side effects of a medication,
Then you definitely do not want the crowd guessing.
exactly. I don't want the creative interpretation of a dosage. I want the facts.
And that brings us to the final and perhaps most important piece of the puzzle for modern business AI. RG.
Retrieval Augmented Generation. I feel like this is the acronym I see everywhere. It's the buzzword of the year.
It is, and for good reason. It's how we solve the drunken gossip problem.
So we're back at the party. The gossip is flying. The facts are getting fuzzy. How does RA save the day?
Imagine that back on the highway while your friend was fixing the tire, there was a bystander.
Okay.
Someone you didn't know. They saw the whole thing, thought it was cool, whipped out their phone, and recorded a video.
Okay, so now we have hard evidence. A video file.
And they uploaded it to YouTube. Now, fast forward to the party. The telephone game is happening. People are saying, I bet he drives a Ferrari.
Mm-hmm.
But suddenly, one of the guests, one of the hidden nodes, pulls out their smartphone.
They have internet access.
They do. This is the retrieval part. They search for the event online and they find that YouTube video.
Huh.
They hold the phone up to the group and say, hey, wait a minute, look at this.
That changes the entire dynamic of the conversation.
Completely. Now, they aren't just relying on what the person before them said. They are looking at a primary source.
They can see the specific uniform. They can see the make of the car. They can see that it wasn't raining.
Right.
These are indisputable facts that were never in your original verbal story.
So now the node can say, actually, he wasn't driving a Ferrari. He was driving a Ford F-150. Look, it's right here in the video.
So RI is basically giving the party guests permission to fact check.
In a way, yes. It is giving the neural network access to non-parametric memory.
Whoa, fancy term. Let's break that down.
So parametric memory is what the nodes know inside their own heads. The gossip, the training data, the weights. That's what they came to the party with.
Like?
Non-parametric memory is external data. It's the YouTube video or a company database or a medical journal. It's information that exists outside the neural network.
That distinction is so helpful. The neural network is the crowd talking. RAG is the crowd being able to look stuff up to verify what they're saying.
Correct. Ortega compares this to MCP Server Technology Model Context Protocol.
Mm-hmm.
It's creating an environment where the nodes aren't just limited to their internal training data. They can reach out, retrieve verified data, and augment their generation with those facts.
So now when those stragglers at the output layer come back to you at the end of the night, they aren't just guessing.
No. They might say, we heard a lot of rumors, but we also saw the video. He was wearing a blue mechanic's jumpsuit, driving a Ford F-150, and he used a lug wrench.
Which makes the output a hybrid.
Exactly. It still has the conversational flow and the social vibe of the party gossip. That's the generation part.
Right.
But it is anchored by the hard facts retrieved from the external source. That's the retrieval part.
This really explains why companies are so obsessed with this.
It does.
Because you get the best of both worlds. You get the AI that can speak fluent English and summarize things nicely, but you also get the accuracy of a database.
You need the creativity of the language model to explain the concept, but you need the retrieval system to ensure the concept is true.
Yeah.
Without RAG, you are just trusting the telephone game. And as we know, the telephone game's fun, but it's not where you want to get your medical advice.
Definitely not. So let's do a quick recap of this journey, because we've covered a massive amount of ground without doing any math.
Let's map it out.
Okay. The input layer. That's me arriving at the quiet party and telling the first 5 people about my flat tire.
Check. That represents raw data ingestion.
The hidden nodes. That's the rest of the party filling up and playing the telephone game. They add their own interpretations and assumptions.
Check. That represents the processing layers where weights and biases shape the signal.
Transformers. That's me wandering around the room correcting people when they get the context wrong. Highway, not bar.
Check. That represents the self-attention mechanism, keeping the story coherent.
The output layer. The stragglers at the end of the night agreeing on a final version of the story to tell back to me.
Check. That represents the probabilistic output.
And finally, RG. Someone pulling out their phone to show a YouTube video of the actual event, injecting hard facts into the conversation.
You've got it. You essentially just described the full architecture of a large language model using nothing but social anxiety and a flat tire.
It's honestly kind of a relief. Because when you strip away the jargon, it turns out AI is just modeled after how we interact.
Yeah.
It's social.
That is the big takeaway for me. We often think of AI as this cold, calculating machine, but neural networks are biomimetic. They mimic biology, and specifically, they mimic our social structures. The strength of a neural network, much like a party, comes from the diversity of the nodes.
That's a really interesting point. If you invited 50 clones of the exact same person to the party, the story wouldn't evolve, would it?
No, it wouldn't. If every node had the exact same weight and same perspective, the output would be identical to the input. You wouldn't get any learning. The creativity comes from the friction. It comes from the fact that node A thinks differently than node B.
But that same friction is also where the hallucinations come from.
Exactly. It's a double-edged sword. The same process that allows the AI to write a creative poem is the same process that makes it invent facts.
Right.
That is why the architecture matters. You need the friction for creativity, but you need the transformer and array for accuracy.
It makes you think about the design of these systems. We're basically building these massive digital cocktail parties inside server farms.
We really are. You know, there's one thing that sticks with me about this analogy. In the end, the output nodes tell the story back to you. The AI is trying to communicate with us. It's a loop.
It is a loop, and that's a crucial point. Think about it. Why did you tell the story to the party? Because you wanted to share.
Sure.
Why do we ask the AI for an answer? Because we don't want to process all that data ourselves.
Right. I don't want to go talk to all 60 people to find out what the consensus is. I just want the summary.
Exactly. The value of the AI is that the stragglers summarize the gossip so you don't have to attend the whole party. That's the utility.
I love that. AI, for when you want the gossip but don't want to socialize.
You should put that on a t-shirt.
So thinking about the future here, we have this party model. We understand Raja. Where does this go next?
Well, if we follow the analogy, the next step is improving the quality of the guests and the speed of the gossip.
We are seeing models that can handle much larger parties, millions of nodes, and we are seeing RG systems that can pull up not just a YouTube video, but the entire Library of Congress in a split second.
The party's getting bigger and the smartphones are getting faster.
Exactly. But the fundamental dynamic, the social exchange of information remains the same. It's still about context, connection, and correction.
It's funny, we started this deep dive talking about how intimidating the math is, but when you look at it this way, it feels almost familiar.
Yeah.
Like we do this every day.
We do. We are neural networks. We are constantly taking inputs, passing them through our own hidden layers of experience, correcting for context, and outputting our version of reality. AI is just trying to do what we do, but at a scale and speed we can't match.
That is a fascinating thought to chew on.
Here's a question I want to leave the listeners with. If a neural network is effectively just a cocktail party of information playing telephone with data, are we just listening to the gossip of machines? And more importantly, does the quality of the answer depend entirely on who or what nodes was invited to the party?
That is something to think about next time you type a prompt into a chatbot. Who is in that room? And have they had too much to drink?
Let's hope they're drinking water and checking their sources.
Thanks for diving in with us today. Hopefully next time you see a diagram of a neural network, you won't see spider webs. You'll just see a bunch of friends sharing a story about a flat tire.
And checking their phones for the facts.
Exactly. We'll catch you on the next deep dive.
AI Automation Alchemist Podcast.